Look around. We live on a perfectly balanced, breathtakingly vibrant world. In an incredibly vast and seemingly empty universe, our planet is a rare, living oasis, holding oceans of water, stable climates, and an astonishing variety of life. This modern stability rests on a foundation of billions of years of apocalyptic trauma. The quiet world outside your window is the result of a long series of global catastrophes. Roll the clock back. Everything we know was once compressed into a single microscopic point of energy that blew outward, eventually swirling into a solar system. Early Earth churned as a globe of magma and toxic gas, a world of non-stop volcanic fire and suffocating heat. So how do you get from a raging sphere of lava to a biological paradise? The answer lies in the destruction itself. Every global catastrophe this planet endured was actually a crucial birthing ground for a biological miracle. Take our oceans, for example. The liquid water you drink today didn't originate on a cooling Earth. It fell from the sky. For millions of years, the planet endured a relentless bombardment from deep space meteorites, massive, dirty snowballs that vaporized on impact, eventually filling the massive basins of our world. Then came an impact that dwarfed the rest. A Mars-sized planet we call Theia slammed directly into Earth. The collision ripped away massive chunks of the planet's crust, throwing glowing debris into orbit. That debris coalesced into our moon, whose gravity locked our wild rotation into a stable 24-hour day. Down on the surface, the chaos continued. Endless volcanic eruptions were tearing through the crust, spewing carbon dioxide and methane, while severe, non-stop lightning storms electrified the toxic atmosphere. Earth was a boiling chemical cauldron. It turns out that specific, highly toxic, electrically charged environment was the perfect recipe for biology. In the 1950s, scientists simulated this exact primordial soup in a lab, firing electrical sparks through early Earth gases. Within days, the mixture produced amino acids, the foundational building blocks of DNA. Without the brutal celestial traumas of early space, the endless icy bombardments, the planetary collisions, and the volcanic storms, Earth would be completely dry and chemically inert. The violence provided the raw materials. But having the ingredients for life doesn't mean life gets to thrive. Around 2.5 billion years ago, global temperatures plummeted to -18 degrees Celsius. The oceans completely froze over in a period known as Snowball Earth. For the simple, single-celled organisms that had emerged in the oceans, this was an apocalypse. Trapped beneath miles of solid ice and darkness, these stagnant cells were forced to rapidly divide, mutate, and adapt just to survive the pressure. The deep freeze finally broke when subglacial volcanoes erupted, filling the air with enough carbon dioxide to trap the sun's heat. As the ice melted, newly evolved complex plant life exploded across the ocean floors, absorbing that CO2 and furiously pumping out oxygen. That near-death experience was the ultimate biological crucible.
The severe stress of a frozen planet forced life to upgrade from simple single cells into complex multicellular organisms capable of breathing oxygen. Fast forward to about 65 million years ago, life had not only survived, it had conquered. Dinosaurs were the apex predators, reigning completely unchallenged across the land, deep within the seas and high in the skies. But deep in the solar system, a 27-kilometer-wide asteroid was drifting. Nudged slightly off course by Jupiter's massive gravity, that rock was put on a direct 22,000-mile-per-hour collision course with Earth. It slammed into the modern-day Gulf of Mexico. The impact instantly vaporized rock and metal, launching a global firestorm and triggering a mega tsunami that stripped the continents bare. This chart shows the catastrophic drop in global biodiversity immediately following the impact. Within a terrifyingly short window, 75% of all plant and animal species on Earth were completely eradicated. The dinosaur empire was gone, but that sudden void was an enormous opportunity. With the massive predators eliminated, a tiny 6-inch mammal that had been hiding in the shadows suddenly had the entire planet to itself. Having survived the ash and the cold,
Our distant ancestors left their burrows and started to multiply. Millions of years later, those mammals evolved into primates living in the lush forests of Africa. But the Earth wasn't done shifting. Tectonic plates deep underground collided, forcing up massive new mountain ranges that shattered the local monsoon cycle. The rain stopped. Slowly, the endless green canopy died off, replaced by flat, sprawling grasslands. The tree-dwelling apes living there faced a stark choice: adapt or starve. To spot predators over the tall grass and travel vast distances for food, they were forced to descend to the ground and stand on two legs. The demands of this new, harsh environment incentivized higher intelligence and bipedal movement. Our biology reflects these ancient survival pressures, shaped by the need to navigate a world that had suddenly turned hostile. When you look closely at the math, our existence is highly improbable. If the icy meteorites had missed, if the rogue planet Theia never struck, or if the African forests hadn't dried up, human beings would not be here. We are quite literally the children of catastrophe. Today, we are witnessing the onset of a new mass extinction, driven for the first time by the actions of a single species. This shift isn't being caused by an asteroid or an ice age. Through relentless industrial pollution and massive carbon emissions, we are rapidly altering the very atmosphere we spent billions of years inheriting. We are systematically unbalancing delicate ecosystems, burning through natural resources, and driving species to extinction at a pace rivaling the asteroid impact. Make no mistake, the Earth itself is not fragile. It has survived oceans of lava, global ice shields, and planetary collisions. The planet will survive us easily. But if we don't correct our course, humanity will simply become exactly what the dinosaurs became, just another layer of fossils in Earth's long, violent history.